Welcome to my video on factoring perfect square trinomials, part 1. In this video we are going to talk about how do we factor perfect square trinomials down into a squared binomial. These are all going to start off as quadratic expressions, so we'll have something like ax squared plus bx plus c, and when we're done, after we've factored it, it's going to be something that looks like this: d times x plus e squared. D and e will be whatever we need from this. So I'm going to show you how can we take a perfect square trinomial and change it into a squared binomial. And you can't do this with every single quadratic expression. Okay, these are special ones, and this is going to be kind of like a little shortcut of how to take it from this and put it into that form. You may have watched my other videos on factoring quadratics and know the diamond method. Diamond method will work for all of these, but if we notice that it is a perfect square trinomial, this is a little bit of a shortcut to get us to our factored state. So with that said, let's take a look at our first perfect square trinomial, how we can tell that it is a perfect square trinomial, and then what can we do to factor it. Alright, we have here x squared plus 2x plus 1, and this is a perfect square trinomial, and the reason I know that it is takes 3 quick steps. The squared term up here, x squared, this has to be a perfect square, and it is because x squared is x times x. The constant at the very end has to be a perfect square as well. 1 is a perfect square because it's 1 times 1. And those two can happen, but it is really determined by the b term if this is going to be a perfect square trinomial or not. So what we're going to have to do is first look for a, whatever's in front of the x squared. If there's nothing there, remember it's a 1. And if it's a 1, all we have to do is take the b term, which is 2, cut it in half. So cutting 2 in half is 2 divided by 2, and then square it. And if that number gives us the constant in the end, this is a perfect square trinomial. Let me say that again. If the first term, the squared term, is a perfect square, the last term is a perfect square, and then the middle term cut in half and raised to the second power gives us the same number as the constant term, we have a perfect square trinomial. So this one is 2 divided by 2 is 1, 1 squared is 1, so this is a perfect square trinomial. We can factor this, and all we got to do is take the variable from the front, the square root of it, it's x squared. The square root of x squared is just x. Take the square root of the constant term, the square root of 1 is 1. And then take the sign of the b term, which is positive. So it'll be x plus 1 squared. This is our answer. We have successfully factored this perfect square trinomial into a squared binomial. And if it meets those 3 little checkpoints, the first term being a perfect square, the last term being a perfect square, and the middle term cut in half squared gives us this number, then we're good to go. So let's try another one. Let's see what it would look like if we have a little bit different setup. This time, let's try x squared minus 4x plus 4. Okay, is this a perfect square trinomial? The first term, x squared, is a perfect square. It's x times x. The last term, the constant, 4. 4 is a perfect square. It is 2 times 2. And then lastly, is the middle term cut in half and squared the same as this? So let's take that negative 4, cut it in half, so we're going to divide it by 2, and square it. You cut it in half by dividing by 2, and then you raise it to the second power. Well, negative 4 divided by 2 is negative 2 squared, and negative 2 times negative 2 is a positive 4, so that gives me the number here. So yes, this is a perfect square trinomial. We can factor it down. What's it going to be? Take the square root of x squared, meaning I'm just going to take one of these x's. Take the square root of 4, so I'm going to take one of these 2's. Take the sign from the b term. It's negative, so we are subtracting. And then square the parentheses, and we are done. We have successfully factored this perfect square trinomial. But what if it isn't a perfect square trinomial? What can we do then? So let's take a look at one that is not going to factor out properly. Alright, so here I have x squared plus 6x plus 16. And we don't know if this is a perfect square trinomial, so let's do our 3 quick little checks. Is the x squared term a perfect square? Yes, it is. It is x times x. Is 16 a perfect square? Yes, it is. It's 4 times 4, so everything's looking good so far. Now we got to check with the middle term, 6. We're going to take that 6, we're going to divide it in half, and then we're going to square the whole thing. And hopefully it gives us 16. If it does, this is a perfect square trinomial. And if it is not, or if it doesn't give us 16, then it isn't. So 6 divided by 2 is 3. 3 squared is 9, which is not 16. So this is not a perfect square trinomial. You would have to use something like the diamond method or something else to factor this. So we're going to say that this is not factorable by the shortcut. Okay? Can't do this one with what we're focusing on in this video. And there we have it. We have done 2 examples where we get a perfect square trinomial, one example where we didn't, and we can't factor it using the methods specifically for this video. We are going to look at one quick video, or one more quick example, because everything we did worked out nicely. There were whole numbers, but what if it's not a whole number? So let's take a look at one more example. Alright, here's our final example. X squared plus 3x plus 9/4. And you could put it as 2.25, but for the sake of simplicity, we're going to keep it as a fraction, 9/4. Do we have a perfect square here? Yes, x squared is a perfect square. X times x. Is 9/4 a perfect square? Maybe you know it is, maybe you don't. So if we're not sure, we can do the check with the middle term. And if it turns into this, it is a perfect square. And if it doesn't, then it's not. So we're going to take that 3, and we're going to cut it in half, and we're going to square it. Now, 3/2 is 1.5, but I don't want to deal with decimals. I want to keep it as a fraction, so it's not going to divide out to a whole number, so we're going to leave it as the fraction 3/2, and we're going to square this. So 3/2 squared is the same as 3/2 times 3/2. When you multiply fractions, you multiply top times top, so that's 3 times 3, 9, and it's over bottom times bottom, 2 times 2, which is 4. So that is a perfect square trinomial. Everything worked out. Great. Now we can factor it. We can use our little shortcut and factor it. And what's it going to be? Well, we're going to take one of the x's, we're going to take the square root of 9/4, which is one of the 3/2s that we had. So 3/2. We're going to square that grouping, and don't forget we need the sign from the middle term. So plus, so it is x plus 3/2 squared. There we go. Now you could be asked to solve from this point on. Solving is from a different video, but just as a quick little reminder, we would take x plus 3/2, set it equal to 0, and then get x alone. So we can subtract 3/2 from both sides, and we get x equals -3/2. And that would be the solution for this quadratic equation. But you don't have to worry about that unless it tells you to solve the quadratic equation. But there we go. Factoring perfect square trinomials using this nice little shortcut. Hopefully this helps, and good luck.